Hello, my name is Nicholas Nakowitz, and I'm a computer engineering major for Group 6's project, the Battlefield Effects Simulator Robot, and I mainly focus on the hardware aspects of this robot. This project came to light when the U.S. Army Department of Defense expressed a need for a modular open system architecture live firing robotic platform that will support the training of the U.S. Army soldiers. Currently, the U.S. Army soldiers use pyrotechnics when training to represent live hostile threat fire and vehicle kill indicators. These pyrotechnics are stored, shot out of what is called a battlefield effects simulator, or a BES for short. When the BES is empty of pyrotechnics, the training must come to a halt, and humans must enter the training zone to reload these pyrotechnic canisters into the BES. Although this method of training has proved to be effective, it still has some drawbacks like the lack of reality and lack of safety. The U.S. Army DoD's expressed interest in an autonomous robotic system was the main motivation for this team to create a system that can be utilized on long fire ranges and maneuver over rough terrain to and from desired locations, actively firing pyrotechnics when proper signals are sent.
Hi, my name is Julia Kemper, and I'm a computer engineer for the Battlefield Effects Simulator Robot project. I focused on the software aspects of this robot. The Battlefield Effects Simulator Robot is a small-scale prototype of the robot that the U.S. Army will continue to develop in the future. The robot this team has built uses ROS, or the Robot Operating System, to accurately maneuver from point A to point B using a map it has created itself utilizing the LiDAR data, as you can see in this video. It then determines if its 3 specified safety signals are met, and then fires the pyrotechnics from the BES if they have been met. The main thing that has motivated this team and kept us focused on our deadlines is the outcome this project will bring. Creating an autonomous robot for the training purposes that Nicholas has described will allow the Army to increase training realism and feedback and improve safety measures during training by removing the human element when it comes to pyrotechnic handling and replacement. My team has taken pride in the fact that we are able to improve these aspects of training to provide the U.S. Army soldiers with a stronger and overall a more realistic training experience that can help to better prepare them for the battlefields.
Hello, my name is Jared Rimkos, and I am a computer engineer for the Battlefield Effects Simulator Robot. We are working with PEO Stry as our sponsor to develop this robot. We have made it a priority to meet with our sponsors weekly in order to develop requirements, goals, and desired outcomes for this project. This has allowed our group to continuously update them on the progress we have made for the project and to gather any feedback they have. We have received quite a bit of feedback from our sponsors on the requirements of this robot. To ensure we are incorporating all the feedback from our sponsors, but not pushing our team's timeline too much, we have prioritized what requirements are most vital to our sponsor and will implement those into our project. All other requirement feedback will be implemented only if time permits. This is a method that both the team and our sponsors agreed upon and is commonly used in the industry. I was primarily responsible for creating the graphical user interface that would select the location of the robot that it would travel to. Our weekly meetings with our sponsor allowed me to demo the progress I was making on the GUI and have a quick turnaround with implementing the feedback they provided.
My name is Michael Rodriguez, and I'm an electrical engineer for the Battlefield Effects Simulator Robot. I mostly focus on the hardware and wiring of the robot. When implementing all of this feedback we received from our sponsors, we made sure to thoroughly go through every piece of feedback with the team and sponsors to ensure we fully understood what our sponsors were asking for. After developing the requirements for the feedback, we then developed our test plan. This plan included how to reach the requirements that we would meet. The various methods we could use to do that, testing our initial and best design, and revising when necessary. For example, a requirement of a robot includes that it should only fire pyrotechnics when the proper safety signals are met. Our team developed a plan for what the said safety signals should be and how they will be determined as met. One of the safety signals is that the robot should not be on more than a plus or minus 10-degree slope when firing the BES. We then decided to use an IMU to verify the robot met the safety signals. After we determined an IMU would be the best course of action, we then investigated which IMU would work best for our system. And finally, we integrated the IMU with the system and ensure it would work properly for what we needed. After this process was completed, we then met with our sponsors to review the plan of action and note any feedback they had.
We will now provide you with a brief demo of the robot. The robot must be first powered on by the Raspberry Pi and be logged into the Ubuntu account, which is remotely shared to another computer so the robot can be entirely wireless. Next, we start to file that our team has created that will spin up our odometry files, cost map files, and others. Next, RViz, the ROS graphical user interface, used to display the map our robot created in the environment, will launch. From there, our team loads in the map of the environment and the robot will be navigating through it. Next, a user will select in the GUI which destination the robot will travel to. Now you can see the robot navigating through its environment. One side of the screen shows the robot and the world moving, and the other shows the robot moving in the map it has created. You can also see the LiDAR data in red that the robot uses to detect any obstacles. As you can see in this video, the robot detects the cone and then travels to its specific location and moves around it. Once the robot arrives at its destination, it will check to ensure it is level via the IMU. Then it will use the GPS to make sure it is in the correct location. From there, we have the ability to access the command driver for the BES, and it is fired. The beeping sound heard in this video is a representation of the BES firing pyrotechnics.
The biggest lesson learned this team has experienced throughout this project is how interacting with the actual industry works. Our team has been used to working with primarily other students and professors. This is the first experience many of us have had working with industry partners on an actual project. We have had to follow the standards that our sponsors use when developing and creating a project. This has included having to accomplish requirements that exceed the expectations of our senior design class, but the Army expects as part of their standards for this process. The accomplishments our team has achieved over the course of the last semester can be seen here. We have also had the opportunity to attend ITSIC, the world's largest modeling, simulation, and training event, to brief Army leadership, including the PEO, who is equivalent to a 2-star general, the DPEO, PEO Strike Chief Engineers, the UCF Board of Trustees, and the Ensign National Director of the Pentagon. This has been a great experience for us as students who are preparing to enter the workforce, and we will absolutely apply the knowledge we have gained during the process of project creation, implementation, and execution during this experience for future work endeavors.